This time we will study the midpoint formula. This is exactly what the name says. It's a formula to give you a midpoint. Midpoint comes in many flavors. The easiest one is the first dimension midpoint. So here's a first dimension is a fancy name for straight line. So you got this line here, and this is 2 and 14. You can think of this as a coordinates 2 and 14, or you can say this is say movie theater that is 2 miles away from your house, and this is something academic, a library that is 14 miles away from your house. Now, you live pretty far from the library. Where is the midpoint between, assuming this is on a straight road, you cannot go the opposite direction for this. So assuming this is on a straight road, this is Main Street, 2 miles away and 14 miles away. Where's the midpoint? So this is how you make an appointment with your friends. Hey, let's meet at the midpoint between the movie theater and the library. That way you can avoid meeting your annoying friends. But where is the midpoint? You could make a grid like that and start counting and come to here. Because right now we are assuming that we don't know where this is, right? We are trying to find the value here. How would you find the middle one? Let me tell you, the easiest one, you will eventually discover anyway, is that you average them. So truly, it's average. 2 plus 14 divided by 2. So what would that be then? It's 16 over 2, so it's at 8. So this midpoint is at 8. You may say, I could have counted this way and made a grid and do the computation and like that. But what if this was 2.14 and this was 14.0026? Not possible. What if this was a square root of 2 and this was a pi? Where's the midpoint between pi and square root of 2? Do you know? I know. It is at, obviously, square root of 2 plus pi over 2. It's as simple as that. So on the same token here, through the same logic, they don't even have to give you a friendly number like 2 and 14. You often say, I want a car so that I can go from point A to point B. They're right there. There's point A and point B. That's what cars are for. Where's the midpoint between A and B? It's A plus B over 2, assuming A and B were the number for the coordinate. I'm not saying A is the name of the point here. I'm saying the A is the coordinate. So this is a variable. So that's all there is for the first dimension straight line midpoint formula. Of course, I would not have mentioned the first dimension and all unless there was second dimension coming in. So this is in second dimension. It's a fancy name for a plane, a computer screen, or piece of paper. They're all second dimension. Flat surface is all second dimension. If you had 2 points here, look at that. Suppose this coordinate was 1, comma, let's be real. It's on negative side. So it's a negative, say 3, comma 1. And let's see, seems like 5, comma 3. What's the midpoint between these two? Now, this is getting intriguing, eh? But no problem. Just average them. But what do I average? Well, average x with x and y with y. So you would have two numbers. These are also point in the coordinate plane. Every point has two numbers in it, don't they? Doesn't it? So here, A will be the negative 3 plus 5. See, what do I do with the negative? Just add the numbers. Blindly add the numbers. Don't think about it's on the left side or below the x-axis. Don't worry about it. Take the number and add it, and bam. What about this 1 and 3? They're both positive. What do I do? Just add them and divide by 2. I ran out of space, so I'll write here. So shall we do this arithmetic? Can you handle this? Negative numbers and all. This is 2 over 2, so it's 1. And this is 4 over 2, so it's 2. So I'm saying this coordinate is 1, comma 2. That's how you do this. This book doesn't show, but you could do the same in third dimension. Basically, you just have 3 pairs to deal with and average each corresponding one. So you would average these two together, and then you would average these two together. In 3D, you would have another number coming, and you would average those third numbers together and put on the third spot. In fourth dimension, it sounds fancy in our imagination and in our modeling. Visualization is very challenging, but in math it's easy. If you have, A, comma, B, comma, C, comma, D, you just specify the point in fourth dimension. And if there's one point like that, there's a E, comma, F, comma, G, comma, H, another point in fourth dimension, you can find the midpoint of these 2 points in fourth dimension. That's nothing but A plus E over 2, comma, B plus F over 2, C plus G over 2, D plus H over 2. That's all there is. So do this a few times, and if friends step by and you say, oh, I was busy doing some fourth dimensional computation, which is completely true. So next time a physicist says I did this computation in fourth dimension, you just snort. I do that too for my lunch. Now let's get back to this. Everything I said is true. It is. That's how it is done. Now, if you have these 2 points that are specified with x sub 1 and y sub 1 and x sub 2 and y sub 2, first let me tell you about the subscripts. If I do x super 2 like that, then this is an operation. It means x times x. But what if I put it under here? What does that mean? It just tells you these are different x's. Don't get mixed up. Then obviously you are going to say, then why didn't you just say A, B, C, D? I mean, why do you have to use x1, x2? Thing is, if I told you, Q, does it stand for x coordinate or y coordinate? What if this was third dimension? What is fourth dimension? So all those variables, letters it's kind of confusing when you start, naming coordinates with it. We kind of want to know it was standing for the x coordinate or y coordinate. And also, you could have lots of points. Then you run out of alphabet. You would even run out of the Chinese alphabet, which is something like in the thousands. So what do? We name them x and y as they are to specify this is x coordinate and y coordinate. But clearly this point is in a different location than that location. So this cannot be the same variable. Same variable x and x got to stand for the same number. So how do we keep the x and differentiate them? We use subscript. So subscripts are not mathematical operations like superscripts. However, these are just a way to specify axes, and they are different axes. Don't interchange them. That's what they're telling you. So enough of x's and all y's there. So if you want the midpoint, again, it doesn't have to even be a number. It could be a letter. It stands for x midpoint, is first x value, x coordinate, plus second x value, then average it. And then average y's, then you get y midpoint. See? By sticking to this x and y and using the subscripts to differentiate them, the picture becomes a lot more clear. So here's the theorem 22. Midpoint in any dimension is the average of their coordinates. Of course, do not average x and y, please. They never mix. Average x's with x's and y with y's, y's with y's. And then you will find the midpoint in any dimension. You can venture into the 13th dimension midpoint. That will impress your friends.